Alright, today we're going to talk about our third and final category of compounds that have their own unique nomenclature system. We're going to be talking about acids. And acids are a category of hydrogen-containing compounds that are named with their own special naming system. For our purposes, we're going to think of acids as any compound or substance whose molecule produces hydrogen ions when dissolved in water. So when we see acids, the hydrogen is always going to be listed as the first element. So a very simple example is HCl, which you've probably used in the lab sometime this year already. Hydrochloric acid, when it dissolves in water, it splits into the hydrogen ion and the chloride ion. And what we're going to see, and this is the main idea for today, is that the name of that negative ion, the anion, determines the way that we name the acid over on the other side. So again, the name of the anion determines how we name the acid. So again, remember that acids contain hydrogen. They have the anion connected to enough hydrogens to actually neutralize it. Let's practice that. If you have, for instance, the carbonate ion, which is CO3 minus 2, if you want to have that in acid form, it needs enough hydrogen ions to balance out the negative 2 charge. So since the hydrogen is positive 1 and the carbonate is minus 2, you need 2 hydrogens to cancel out the carbonate. Another way to think of it is do the crisscross rule. So it becomes H2CO3. And this is called carbonic acid. And again, the name of it, carbonic, is determined from the name of the anion, which was carbonate. So those are the rules that we're going to talk about now. So this diagram here is showing us how the anion name leads us to the acid name. So there's 3 possibilities for what the anion might end in, and that determines how we name the acid. So possibility 1 is that your ion might end in the "ide" ending. So chloride is an example. Another example might be fluoride. We'll use that as our kind of alternate example. So what you do is you take that "ide" ending and you get rid of it, and you have a little root left over, like maybe chlor or fluor, and you insert that little root right in here, chlor or fluor. So chloride, when you pair it up with hydrogen, becomes hydrochloric acid. Fluoride would become hydrofluoric acid. So I have a little kind of sentence to say that helps me remember this rule. I say my ride, which is another word for like my car. My ride has hydraulics. And I'm going to spell it wrong. Okay, just go with it. So my ride has hydraulics. This is kind of describing those cars that bump up and down. Okay, so "ide" is the name of the anion, so chloride, fluoride, has hydraulics. The hydroic part of that word represents the acid name. Okay, so "ide" ions become hydroic acids, and we'll do some extra practice with that. Okay, the next possibility, option 2, is the ion might end in "ate." So chlorate or perchlorate, or let's go with carbonate, my example from earlier, carbonate. So you get rid of the "ate" ending and you just have a little root left over. So chlorate becomes chlor, perchlorate becomes perchlor, carbonate becomes carbon. And you take that root and you insert it right here with the "ic" suffix. So chlorate became chloric acid, perchlorate became perchloric acid, carbonate would become carbonic acid. So the next little sentence to remember is I ate it and it made me sick. And again, I'm going to spell sick wrong. Just go with it, S-I-C. So I ate it, that represents the ion ending, and it made me sick. The "ic" represents the acid ending. So that's your second kind of mnemonic device or memory sentence to help you remember the ion and the acid names that go together. The third possibility for what the ion might end in is "ite," so chlorite, hypochlorite, or so on. You get rid of the "ite" ending and you have a little root left over, and you take that root and you insert it right here. So chlorite became chlorous acid. Hypochlorite becomes hypochlorous acid. Another example might be nitrite, okay, which is NO2 minus. That would become nitrous acid, and you'd crisscross it and get HNO2. So our final sentence to help us remember these things: the spider bite, which nobody wants, ite, was poisonous. The spider bite, ite ending, was poisonous, O-U-S ending. Okay, so ite and us go together. So let's do some practice here and kind of see what type of things you need to be able to do. So the first one, HCN. The first one, HCN here, we look at the anion and think about what was its name. CN, the ion, is cyanide. Okay? You don't have to write it out, but this is kind of the thought process that you need to go through. Ide ending. Which of my little sentences had an ide in it? My ride has hydraulics. So this is going to be a hydro something ic acid. And the little root that you plug in there is whatever came before the ide, which is cyan. So the name of HCN is hydrocyanic acid. Awesome. The next one, HNO2, I actually just did, but we did it the other way. So let's think about the NO2. NO2, the ion, is nitrite. Okay, so the ite ending, what sentence had ite in it? The spider bite was poisonous. So we get rid of the ite and change it to us. So this is nitrous acid. All right, one more. H2SO3. Again, the fact that it has two hydrogens doesn't really matter as far as naming goes. It only is there because of the crisscross rule. It's the charge of the SO3 ion. But for naming it, it doesn't matter. Let's just think, what is SO3? SO3, the ion, is sulfite. Okay, so again, you get rid of the ite. This is the same as before. So this would be sulfurous acid. Now, I always have students who write like sulfus acid because sulf is really what came before the ite, and they literally just take off the ite and put on the us. If you wrote sulfus acid, I would give you credit for it, but as we go through chemistry, we kind of realize that there's a bunch of exceptions, and this is one that you'll just pick up on. It's sulfurous, or if it was H2SO4, it would be sulfuric. You'll just pick up on it. All right, the next examples, we're going to go the other way. So we have the name, and we want to write the formula. So we kind of go the opposite way in our sentences. This time we have the ending, and we need to think, what ion did that come from? So permanganic acid, ic acid, think about what sentence that came from. I ate it, and it made me sick. So permanganate is the ion that we're dealing with here, which is MnO4 minus 1. So that's the anion, but that's not the acid. The acid is when that ion is paired up with hydrogen. So we write the H plus in front of it. We think about doing the crisscross rule. This one's just 1 to 1. So it's HMnO4. Okay, so that's the acid formula for permanganic acid. And our last example here, dichromic acid, same thing. It ends in ic, so we know that came from the 8 ion. So that would be dichromate. So dichromate is Cr2O7 minus 2. That's just the ion. The acid formula is going to be when that's paired up with H+. So we put it with H+, and we do the crisscross rule. So I bring the 2 down there, and the 1 goes down there. So it's H2 Cr2O7. So here's all our answers. All right, here's a couple more practice problems that we'll do together. Hydrobromic. So hydro something ic. My ride has hydraulics. So I need to think about bromide. Bromide is Br minus 1. Put it with hydrogen to get the acid, H+, becomes HBr. Okay, now bromic. This sounds kind of similar, hydrobromic versus bromic, but obviously this one had the hydro in it and this one doesn't. This one's just the ic, okay? So this one is I ate it and it made me sick. So this is going to be from bromate, the ion, okay? Bromate is BrO3 minus, and we're going to pair that up with H+ and get HBrO3. Our next one is hypobromous acid. So this one has the OUS ending, and we think about the spider bite was poisonous. So we need to think hypobromite, the ion. okay? Just like hypochlorite. It's BrO minus. Pair it up with the H plus. Crisscrossing, you get HBrO. Perbromic. So we're doing all of these bromines here, okay? Perbromic. Ic, without the hydro, it's just ic, means that it came from the 8 ion, so perbromate. Okay, perbromate is BrO4 minus. Pair it up with the H plus, it's a 1-to-1 ratio, so it's HBrO4. Very good. And iodic acid, okay? Again, just the ic ending means it came from the 8 ion, so iodate. Just like chlorate, iodate is IO3 minus. Pair it up with the H plus, you get HiO3. All right, and last one for this slide, sulfurous acid, us, came from the ite because the spider bite was poisonous, so we need to think sulfite. We actually saw this one earlier. Sulfite is SO3 minus 2. Pair it with hydrogen, do the crisscross rule, and you get H2SO3. All right, so the next couple minutes of this PowerPoint are just going to be some speedy examples on a whiteboard. So feel free to pause it, but mostly just pay attention. A lot of nomenclature stuff is learned through repetition, so I'm just going to show you a bunch of examples real quick right now.